Here we go. Graph of f prime of x, the derivative of a twice differentiable function f on the closed interval from 0 to 8. The graph of f prime has horizontal tangents at 1, 3, and 5. The areas of the regions between the graph of f prime and the x-axis are labeled. The function f is defined for all real numbers, and they gave you the initial condition f of 8 equals 4. So I've read the problem, and I've told you 100% of the time if you have a graph of the derivative, draw a sign chart. So this is on the closed interval, so it starts at 0, it ends at 8, and the first thing I'm going to do is graph what I know about f prime. So if this is the graph of f prime of x, f prime of x is above the x-axis from 0 to 1, 2, 3, 4. Because it's above the x-axis, that means that the derivative is positive. It drops below the x-axis from 4 to 6. So the derivative is negative, and then it is positive from 6 to 8. And then let's go ahead and talk about f double prime. F double prime equals the slopes of f prime. So the slopes from 0 to 1 are all negative slopes. From 1 to 3 are positive. From 3 to 5 are all negative. And then from 5 to 8 are positive again. And then I'm going to go in and write down, what does that mean about f? If the first derivative is positive, f is increasing. If the first derivative is negative, f is decreasing and increasing. So I have a relative max here, a relative min here, concave down, up, up. So because my second derivative changes signs at 1, 3, and 5, those are all points of inflection. Now the AP exam's not going to read my sign chart, but it's nice to have my sign chart that organizes all the data, and then it makes A, B, C, and D much quicker. Find all values of x on the open interval from 0 to 8, at which the function f has a local minimum. Right there, x equals 6 is a local minimum. Because, and when you justify a max or a min, you can either use the first derivatives test or the second derivatives test. Right now, I'm going to say that because f prime of x changes from negative to positive, at x equals 6. Now, I could have also used the second derivatives test, and all I would have had to say is x equals 6 is a critical number because the derivative equals 0, and that the second derivative is positive. If you have a critical number and the second derivative is positive, that means your graph is up like a cup, and that's a minimum. So I could have used the first or second derivatives test. Now, A asks you to justify where you have a local max or min in this problem, and B says determine the absolute min. If you're determining absolute, you have to find the y values, so that means you have to take a look at your endpoints. So our endpoints were 0 and 8, and we found, looking at our chart, that we had a minimum at 6, so I made a sign chart. Then in the problem, they gave me that f of 8 was 4. They had to give me initial condition. So now I'm actually going to go backwards from what you would think. So I'm going to now use where you are equals where you start plus how far you go. I have to use a point I know and a point I'm looking for. So I know f of 8, and I'm going to try and find f of 6. So I know f of 8 is equal to f of 6 plus the integral from 6 to 8 of f prime of x dx. Where you are equals where you start plus how far you go. And this, when I integrate, I'm just finding the area. So f of 8 is 4 equals f of 6 plus, and when I integrate from 6 to 8, my picture 6 to 8, that area is 7 and it's above the x-axis, so it's plus 7. Now to solve for f of 6, I subtract 7 and I get f of 6 equals 3. And now I'm going to apply the same process to find f of 0. So I know f of 6 and I want to find f of 0. So f of 6 is equal to f of 0 plus the integral from 0 to 6 of f prime of x dx. So f of 6 is 3, which is equal to f of 0 plus. Now, the integral from 0 to 6 means I have to have this area, and this area. So the integral from 0 to 6 is going to be 2 plus 6 minus 3. So 3 is going to equal f of 0 plus 5 oh, that was -3 here. Oops, sorry. That was -3. Subtract 7, that's -3. -3, -3. So when I subtract 5 from both sides, that's going to give me f of 0 equals -8. So now that I can look at it, yes, -3 is a relative minimum, but my absolute minimum is -8. And it says determine the absolute minimum value. So that is the y value. So I'm going to write here absolute minimum of -8. Now, my justify for here is my table. Now, an t-chart, x and y, is a good justification. If you're justifying a max or a min, you have to use the first derivatives test or the second derivatives test. Now, C says on what open intervals in 0 to 8 is the graph of f concave down and decreasing. So I'm just going to go back up here and look. Where am I concave down and increasing? So from 0 to 1, I'm concave down and increasing. And then I'm concave down from 3 to 5, but only increasing from 3 to 4. So and 3 to 4. So again, I went back and I looked at my sign chart to see where the first derivative was positive and the second derivative was negative. So my explain my reason is because on those intervals, f prime of x is greater than 0 or positive, and f double prime of x is less than 0 or negative. So A, B, and C were all curve sketching from the derivative. Part D, the function g is defined by g of x equals f of x to the third power. They told you f of 3, find the slope of the tangent line of g at x equals 3. This is asking you to find g prime of 3. Now, this is actually g of x equals anything to the third. So to find g prime of x, it's 3 times anything in this problem was f of x to the second power. So I multiplied, dropped my power by 1. So the derivative of anything to the third is 3 times anything to the second times The derivative of anything is f prime of x. And now I just need g prime of 3, which is 3 times f of 3 squared times f prime of 3. So g prime of 3 equals 3 times. Now, f of 3, they told me, was negative 5 over 2 squared times f prime of 3. I have a graph of the derivative up here. So f prime of 3 is f of 3, and f of 3 is 4. So f prime of 3, I looked on my graph of f prime, and when x was 3, my y value was 4. So this is 3 times 25 over 4 times 4, cancel is 75. So let's real quick go through these points. Every AP problem in the past has been worth 9 points. We don't know this year, but here we go. Number 1 was just plus 1 for the answer and the justification. Part B was worth 3 points, 1 point for considering 0 and 6. One point for your answer, and 1 point for your justification. Your justification was that table or those y values that you found. So we're up to 4. Part C was worth 2 points. It was 1 point for the answer, 0 to 1 and 3 to 4. And plus 1 for your justification, which means D was worth 3 points. You got 2 points for your g prime of x right here. Now, you had to use the chain rule to get both those points. So, and then plus 1 for the answer. This was the hardest of the 3 graph problems. Good luck on your other 2 today.